Hi, and welcome to this Corbettmaths video on the discriminant. In this video, we're going to look at what the discriminant is and how we can use it to solve questions. So if we have a quadratic equation, so something in the form ax squared plus bx plus c equals 0, one way in which we could solve it is to use a quadratic formula, which is of course x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now whenever we use this quadratic formula to solve a quadratic equation, either one of three things could happen. So whenever we substitute in the values for a, b and c into the quadratic formula, one of three things could happen. And it all depends on what's underneath the square root, so in other words, the value of b squared minus 4ac. If this b squared minus 4ac is positive, you get the square root of a positive, and then you have negative b plus that number and negative b minus that answer. And that will give you two different answers for x. So you'll have two different answers for x. So what you'll have is two different real roots. Then, if b squared minus 4ac is equal to 0, that means you'll get negative b plus 0 and negative b minus 0. Well, that'll still just be negative b, and then divided by 2a. Well, that'll give you the same answer twice. So that will be two repeated real roots. So it'll be the same answer twice. It's called two repeated real roots. And finally, if b squared minus 4ac is negative, we'll have the square root of a negative, which will mean we have no real roots. So this part of the quadratic formula, this b squared minus 4ac, is what we call the discriminant. And depending on the value of it, it will tell you the number of roots to your quadratic equation, where you'll either have, if b squared minus 4ac is bigger than 0, you'll have two different real roots. If b squared minus 4ac is equal to 0, then you'll have the same answer twice, so it'll be two repeated real roots. And if you get b squared minus 4ac as negative, you'll have no real roots. The discriminant can also be very useful whenever we're sketching quadratic graphs. So if we have y equals ax squared plus bx plus c, so if we work out the discriminant, our b squared minus 4ac, and we get that it's bigger than 0, we know there's two real roots. And what that means in terms of the quadratic graph is it will cross the x-axis at two different locations. So if we have the discriminant is equal to 0, what will happen is the quadratic graph will go down and touch the x-axis and go back up again, because we have a repeated root, so it touches the x-axis and goes back up again. And finally, if we have b squared minus 4ac is less than 0, there's no real roots, so what that means is the quadratic graph is above the x-axis, it doesn't reach the x-axis. And that's for quadratic graphs whenever it's a positive x squared, so whenever a is bigger than 0. If we have a is less than 0, what we'll get is the same thing, but really the other way around. So if you have the discriminant is bigger than 0, our b squared minus 4ac is bigger than 0, the quadratic graph will go up and cross the x-axis at two different locations. If our b squared minus 4ac is equal to 0, again the quadratic graph will touch the x-axis and go back down again. And finally, if we have b squared minus 4ac is less than 0, the quadratic graph won't reach the x-axis. Okay, let's have a look at some typical questions now. So our first question, find the values of k for which x squared plus kx plus 16 equals 0 has equal roots. So here we've got a quadratic equation and we've been told it's got equal roots. So in other words, it's got two equal roots. And what that means is the discriminant, our b squared minus 4ac, will equal 0. Okay, now if we have a look at our quadratic equation, we have a is equal to 1 because this is x squared or 1x squared. We've got b is equal to k because the coefficient of x is k, and our c is equal to 16. So c is equal to 16. So if we substitute these values for a, b and c into the discriminant, let's see what we get. So b squared, that's going to be k squared, minus 4, so minus 4 times a, which is 1, times by c, which is 16, and that's equal to 0. And then if we simplify this, we get k squared, and then minus 4 times 1 is 4, times 16 is 64, equals 0. And then we want to solve this. We can do it in two ways. We could add 64 to both sides, and then you've got k squared equals 64, and then that means that k equals 8 or negative 8. Or you could factorize it because it's the difference between two squareds, and you get k minus 8 and k plus 8 in the brackets. So that means that k equals 8 or k equals negative 8. So there are possible values for k. So if we had x squared plus 8x plus 16 equals 0, if you solve that quadratic equation, you'll get the same answer twice, so you'll get equal roots. Likewise, if you've got x squared minus 8x plus 16 equals 0, if you solve that, again, you'll get the same answer twice, so we'll have equal roots there. Okay, our next question. So our next question says, find the values of k for which the quadratic equation x squared plus 3x plus k equals 0 has two unique real roots. So in other words, it's got two different real roots. So what that means is the discriminant, our b squared minus 4ac, will be bigger than 0. So let's have a look at our quadratic equation. A is equal to 1, b is equal to 3, and c is equal to k. So if we substitute those into the discriminant, we're going to get b squared, well, that's 3 squared, minus 4 times a, which is times by 1, and then times by c, which is k, and that's going to be bigger than 0. So we get 3 squared is 9, subtract 4 times 1 times k would be 4k, and that's bigger than 0. Now if we add 4k to both sides of the inequality, we get 9 is bigger than 4k. And if we divide both sides of the inequality by 4, we get 9 over 4 is bigger than k. So in other words, k is less than 9 over 4. And that's it. Okay, let's have a look at our next question. Our next question says the equation x squared plus 5px plus p equals 0, where p is a non-zero constant, has equal roots. Find the value of p. Now we've been told it's got equal roots, so that means the discriminant is equal to 0. So let's write that down. b squared minus 4ac equals 0. So b squared minus 4ac equals 0. Now if we have a look at our quadratic equation, we've got a is equal to 1, we've got b is equal to 5p, because p is a number, so 5p is just a number, that's the coefficient of x, so b is 5p, and c is equal to p. Okay, so if we substitute those values into the discriminant, we're going to get, well, b squared, so b is equal to 5p, so let's put that in brackets, 5p, close brackets, squared, minus 4 times a, so 4 times 1, times p. And that's equal to 0, because there's equal roots. Okay, so 5p squared, well, 5p times 5p is 25p squared. Subtract 4 times 1 is 4, times p is 4p, and that's equal to 0. So we want to solve this, so let's factorize the left-hand side, and if we've got 25p squared and 4p, a common factor of those would be p, so we'll have p brackets 25p subtract 4 equals 0. So remember here, if we have p times this equals 0, it means that one of them is equal to 0. So either we have p is equal to 0 or 25p minus 4 equals 0. Now just reading the question, it says p is a non-zero constant, so p cannot equal 0. So we're going to focus on this. So we've got 25p minus 4 equals 0. So we're going to add 4 to both sides of this equation. So we'll get 25p equals 4. And then dividing by 25 will give us p equals 4 over 25. And that's it. Okay, so our next question. So our next question says the equation 3x squared minus 2x minus, and in brackets k plus 1 equals 0, where k is a constant, has no real roots. So that says no real roots, so we know the discriminant is going to be less than 0, so the bit under the square root will be negative, so b squared minus 4ac is negative, less than 0. And we've been asked to find the set of possible values of k. So let's write down our values for a, b, and c. So a is going to be equal to 3. B is going to be equal to negative 2, and C is equal to negative, and in brackets, k plus 1, so negative in brackets, k plus 1. And it might be useful to expand this bracket, so we've got C equals, and remember negative is negative 1, so we've got negative 1 times k, which is negative k, and negative 1 times 1 is equal to negative 1, and that just might be useful whenever we're substituting them in. Okay, so b squared, so we've got negative 2, so negative 2 squared, minus 4 times a, so times by 3, times by, and then we've got our value for c of, in brackets, minus k minus 1, and that is less than 0. Right, so negative 2 squared, well, negative 2 times negative 2 is 4, so we've got 4, and then we've got minus, and then we've got 4 times 3, which is 12, and then we've got our bracket of minus k minus 1, and that's less than 0. So we've got 4, and then we've got negative 12 multiplied by negative k, so negative 12 multiplied by negative k would be equal to plus 12k, so plus 12k, and then we've got negative 12 times by negative 1, which would be equal to plus 12, and that is smaller than 0. Okay, so now let's simplify. So we've got 4 plus 12, so that's 16, plus 12k is less than 0, and subtracting 16 from both sides of the inequality will give us 12k is less than negative 16. And then finally, we just need to divide by 12, so we're going to get k is less than negative 16 over 12, and simplifying that will give us k is less than negative 4 over 3, and that's it. So k is less than negative 4 over 3. So that means that any value of k less than negative 4 over 3 will mean that our quadratic equation has no real roots. Okay, so let's have a look at our last question. So our last question says x squared plus kx plus, and then in brackets, k plus 9, close brackets, equals 0, where k is a constant, so k is just a number, has different real roots. So because it's got different real roots, we know that there's two values whenever we work out the quadratic formula and solve it. So we know that the discriminant, our b squared minus 4ac, is going to be bigger than 0 because it's got two real roots. It's got two different real roots. And we've been asked to show that k squared minus 4k minus 36 is bigger than 0. So let's write down our values of a, b and c. So a, if we look at our quadratic equation, so a is equal to 1, b is equal to k, and our c, our constant, well, we've got k, which is a number plus 9, so it's going to be equal to k plus 9. And now we know our values for a, b, and c. Let's substitute those into the discriminant. So we've got b squared, so b squared is equal to k squared, minus 4ac, so that's minus 4 times 1 times k plus 9. And we know that's going to be bigger than 0. So simplifying this gives, well, we've got k squared, and then we've got minus 4 times 1 is 4, and then we've got our bracket k plus 9, and that is bigger than 0. And then we've got k squared. Now negative 4 times k would be minus 4k, and negative 4 times 9 is equal to minus 36, and that's bigger than 0. And that's it. So part A says show that k squared minus 4k minus 36 is bigger than 0. Well, there we've done it. Okay, part B. Okay, so part B says find the set of possible values of k. So to do that, what we're going to do is we're going to solve our quadratic inequality. So we want to find whenever the left-hand side is bigger than 0. So let's let it equal 0 and find the key points in our graph whenever we do our sketch. So k squared minus 4k minus 36 equals 0. Okay, so let's solve it using completing the square. So open up our brackets, k minus, and we halve this value, so minus 2, close bracket squared. We then subtract this value squared, so 2 squared is 4, so subtract 4, and then we've got our minus 36, so minus 36 equals 0. And then let's simplify, so we're going to have k minus 2, close bracket squared, minus 40, because minus 4 minus 36 is minus 40, is equal to 0. Then we're going to add 40 to both sides, so we're going to get k minus 2, close bracket squared, equals 40. And then we're going to square root both sides, so we're going to get k minus 2 equals plus or minus root 40. Now let's add 2 to both sides, so we're going to get k equals, now whenever we add 2 to both sides, we tend to put it in front of the plus or minus, so we're going to get 2 plus or minus the square root of 40. And finally, let's simplify our root 40. So the biggest square number that's a factor of 40 would be 4. So we've got root 4 multiplied by root 10, and that would be equal to 2 root 10. So we've got to get that k equals 2 plus or minus 2 root 10. Okay, so here's our axes, and we'll do a sketch. So we've got k equals 2 plus 2 root 10, well that's positive, and we'll get k equals 2 minus 2 root 10. Now root 9 is equal to 3, so 2 times 3 is equal to 6, so this is going to be bigger than 6, so you've got 2 minus a number bigger than 6, that's going to be negative. So it's going to look something like this whenever we do our sketch. And on the right hand side, we've got 2 plus 2 root 10, and on our left hand side, we've got 2 minus 2 root 10. So we're looking for the values of k where this is positive. So that's going to be whenever it's above the x-axis. So k is going to be bigger than 2 plus 2 root 10, or k is going to be less than 2 minus 2 root 10. And that's it. So if you have a value of k that's bigger than 2 plus 2 root 10, or a value of k which is smaller than 2 minus 2 root 10, and you substitute that into our equation that we were given at the beginning of the question, you'd find that that equation would have two real roots, and that's it. So the possible set of values of k are k is bigger than 2 plus 2 root 10, or k is smaller than 2 minus 2 root 10. So just to recap, the discriminant is b squared minus 4ac. When it's bigger than 0, you get two different real roots. When it's equal to 0, you get two repeated roots, so the same answer twice. And whenever b squared minus 4ac is less than 0, you get no real roots. And that's it.